Students, in our offline classes, we have learned about the purely resistor circuit that is there in the chapter of alternating current. In today's class, we will learn about the purely inductive circuit that is there in the chapter of alternating current itself. Okay. Now, before moving to the circuit, let's just see that what is the basic circuit diagram for an purely inductive circuit. Let's draw. Circuit I'm writing in short, but in your exam you'll write the full thing. Okay. So this is what the current is flowing. You're having the voltage source here and your inductor is this part. Okay. It is denoted by the letter L, big L. So students, for this circuit, let the alternating voltage that is being applied in this particular circuit be the usual expression that we write. That is, I'm writing here V equals to V naught sine omega t. Alright. Now, if the instantaneous change of current in the circuit be di, so therefore the EMF will be induced. You will get an induced EMF. So the value of this induced EMF in the two ends of the inductor, that means between this and this, the EMF will be generated, and the value of this inductor will be what? Induced EMF will be equal to minus L di by dt. Okay, these students we have discussed in this in the classes when we were discussing about this induced EMF, why this negative sign appears and all that we will see, that I'm not repeating. Okay, now this EMF reduces the main voltage in the circuit. Okay, that means this particular EMF that is being generated between these two ends will reduce the main voltage in the circuit. So for this, the effective voltage of the circuit becomes how much? It becomes V naught sine omega t minus L di by dt. I'm writing here V naught sine omega t minus L di by dt. Okay. This is happening when this particular EMF, it is reducing the main voltage in the circuit. Okay. So a purely inductive circuit has no resistance. Okay. Remember this, very important for your objectives. A purely inductive circuit has got no resistance at all. That means your R part is 0. Okay. So according to Ohm's law, if you just recall the Ohm's law, we can write that means for this inductive circuit, your R is equal to 0. That means from Ohm's law we can write that V naught sine omega t minus L di by dt equals to 0, isn't it? Okay. So we can just place it mathematically. Put this di in the LHS part and all other things in the RHS part. So your di by dt equals equal to V naught by L sine omega t. We can write this. Okay. This is when for the inductive circuit, since it has got no resistance. Alright. So let's do the integration with respect to t, then okay, this is purely the maths part that we are going ahead. Okay, so this will become what? I, integration of di becomes I, and here minus v naught by L, the integration of this will become cos, that means the sine omega t, cos omega t plus k. Don't forget to write this k, this is for your maths part. K means your constant, okay, the integration constant. Okay, so from these students it is clear, that means after doing the integration we can see that the dimensionally k is same as I, isn't it? If you just go through this expression, then you will see that k dimensionally we can see k is more or less similar to the case of I. Also, k is a time independent quantity. Have you seen that there is no time, any factor or any term related to t is there? So we can say that t is time independent quantity. As the source voltage oscillates symmetrically about 0, isn't it? Then what will happen to the current? The current will also oscillate symmetrically about 0. When the voltage will oscillate, your current will also oscillate. For this situation, students, no constant or time independent current can flow through the circuit. Understood? That means when your voltage will also oscillate and your current will also symmetrically oscillate along with the voltage part, then no constant or time independent current can be flown through the circuit. Then your k part will be equal to 0 for that condition. I'm writing here k will be equal to 0 for that condition, students. Don't mix it up. So therefore, if you go back to the previous expression, therefore I will be equal to minus v naught by L cos omega t, which is equal to plus, yes, it's plus just, plus v naught by omega L sine within bracket omega t minus 90 degree. We can write this. This is purely maths part, students. I'm not going to tell in the physics classes. All right. Yes.